You guys asked for it, so we're going to do it today. Today, we're going to be doing a scenario where a client gives me Instagram data, millions and millions of user profiles scraped by Bright Data, the world's #1 web data platform. And we're going to show them how they can use this data to build a machine learning algorithm and then a dashboard for that machine learning algorithm in order to show some really cool insights of what you can learn from web data. Okay, so the first thing we're going to do is we will go to my dashboard on Bright Data, right under the data collection platform, under my data sets. Let's go ahead and download our massive data set. I'm going to go ahead and put it in this folder right over here. It looks like we have about 20 gigabytes of compressed data. So I'm going to let that run, probably grab some coffee and be right back. Looks like we are done with our download. So let us go ahead and open up this file. All right, here we are. So we have our data extracted, and it looks like it came inside a JSON format. So we're going to go ahead and try to take a quick look at the data, and then we'll outline the steps that we'll be taking in order to actually create our quick little dashboard that will use a machine learning algorithm to help us determine where these centers of influence are based on Instagram data. So let me go ahead and create a new Python notebook file. So we'll call this data cleaning.ind, and we'll go ahead and import pandas as PD. Please zoom in for you guys. And then let's go ahead and read our first file. So we'll call this test equals pd.read JSON because we have a JSON over here, and it is inside the data folder. We're on a Windows computer, so we need to use the double backslash. This is called chunk_1.json. And then let us see what the top 5 rows look like. And I also want to see a list of columns. There we go. All right, so it looks like we have an extract of every single account and a lot of columns to go through. So here is our list of columns. Okay, so first of all, let's try and determine what exactly we're going to be creating. So we're going to be creating, go ahead and put this in Markdown. So we're going to be creating a dashboard that uses Instagram profile data from Bright Data to help us determine where the global centers of influence are in using various metrics. We'll use a k-means clustering algorithm. And what that basically does is k-means is a good unsupervised algorithm for helping us determine where clusters of things are using various measures. We're going to be using longitude and latitude, basically x's and y's, and then we're going to be using some other measure to determine, okay, if we have 100,000 accounts, these 10 over here, these 10 over here, these 10 over here, like form different groups of accounts. So what do we need for that? We're going to need the account location. And specifically, we're going to need that in longitude and latitude. And then we're going to need account measures because, so for example, we could have the k-means algorithm devise different areas, devise different groups based on how many accounts are in an area, or like how many followers are there, or how many posts there are. For example, let's just say, for the sake of argument, that New York City and Texas have the same number of Instagram accounts existing within their borders, right? What, even though that might be the case, it's probably more likely that New York City has more followers in general because people all over the world are probably just following creators in New York City. So if we run a k-means algorithm where we're basing it on the number of accounts for our clusters versus we're running a k-means algorithm where we're dividing it based on the number of um, followers in our to devise our clusters, we're going to get two different cluster groups. So that's what the account measures are going to determine. So we need our account measures, and I think that might really be it. Yeah, that honestly might be it. So let's go ahead and limit our, so what are the steps we're going to follow, right? So let's go ahead and put this up here. Steps, limit columns. We need to parse out geographic data. And then we need to create clean data set. So these will be our data cleaning steps. And then let's highlight these over here. And as you can tell, it's really important to plan out what you're going to do before you actually do it. You'll honestly save a lot of time just by doing this instead of just running straight into the problem by planning out what you want to do prior to actually doing it. Next, we're going to create dashboard. And for that, we need to create graphs. And we'll need to create filters. Oh, before that, we'll need to create our algorithm. That'll be a fairly easy thing to do. Create ML algorithm. It should be like a one-liner, it won't be that difficult. Then we create our dashboard. So we'll add our graphs, our filters, and yeah, that'll be about it. I think those are the basic steps we'll be following here. Sweet. So let's go ahead and get started. So let's first go ahead and limit our columns. So I'm going to take this over here and bring it over here. And you'll notice that I'm only working on one file right now. Right? Remember, we have about what looks like 34 JSONs we need to parse through. I always work with one file first, and then make the logic work for that, and then extrapolate that logic from the rest of them. And we'll create a function that actually does that. That way, we are not trying to load all of the data in all at once. So of all of this data over here, I think the only ones we actually need are the measures that we'll be using for our machine learning algorithm and the location. So the location will be the business address JSON, which is probably in there. And then, business category name might be a fun one to have. So we can separate things by business category. Followers is an important one. That's a measure for us. Verify could be an interesting measure for us. Like which city has most verified accounts. Posts count. And I've looked at this data set before, and I know posts is where the bulk of the data is. Like the 40 gigabytes of data mostly comes from the posts because it has all the information about posts in there. So that's a lot of information to parse through. We won't need to do that right now because each individual post doesn't necessarily have a location stamp we can use with it. Let's see. Trying to see, average engagement. This could be very good. And then let's change this to Python. So we have average engagement. Yeah, I think that those are some good categories right there. So let us go ahead and insert commas over here. We will double bracket that. And then if I do this, then you'll see we will have limited our data to just a couple of columns. So once we do that, now I need to parse out the business address.json. So what I'm going to do is I am going to look at what one of these JSONs looks like. So let's go ahead and just look at the first one. So this will be step one here. We'll do that in a second. So what I want to do is I want to get the first column of this data. So we're going to do test, which is the name of our data frame. We are going to look at the first column, and then we'll look at the first row of the first column. And it looks like we have the city name. Oh, cool, there's latitude and longitude right there. Sweet. Easy work for us. So then let's see, what data type is this? Oh, it's a dictionary, even better. Wow. This just gets easier and easier. So if we do dot get uh, latitude, sweet. Awesome. So what we need to do then is we need to go ahead and limit our data frame to just these columns, right? So I'm going to go ahead and do def. I'm going to create a function. Uh, we'll call it data cleaner. And we will say data cleaner is, it accepts a data frame. So dirty data. And let's see, new data equals dirty data. And then we just need to limit the columns. So we'll limit the columns like that. So now we have a data frame called new data, which will be just those columns. And then I guess I'll just create two lists. So we will have a list. So we'll call this latitudes. And that will be, so it looks like we also have a none over here. So I'm curious what happens if we have a none. So let me test that edge case over there. So what happens if you put this index in there where we know there's nothing? Okay, so you get nothing. So we do need to test it out. So what we'll do is we will go ahead and put in latitudes. And actually, we can probably make this a list comprehension. So let's make this a for loop first. So for I in, and then we want to search this column over here. So for I in this column over here, let us go ahead and iterate through each one and then try and do I dot get latitude. And then what I can say is if I dot get latitude, which means that if there is something in there, do this, right? Um, latitude dot append. Um, append this, I guess. Else append latitudes dot append none. So this is our for loop over here, right? Now let's turn that into a list comprehension because those are a little bit cleaner. What I can do is I can do latitudes equals I dot get latitude for I in new, this one up here, if I dot get. So you can do, you can just do if I dot get latitude. That's a shorthand for like if this is true, if there's something there, latitude. Oh, but I need an else also, right? So actually, I forgot how to do that. So list comprehension. If I keep forgetting how to do if else in this comprehension. I really should have it memorized by now. Yes, this if it's true, else something else. Okay. If so like that. So if latitude, else none for I in new data.json. So I think that should work. So let me go ahead and just try this out separately. We'll just put test over here and let's see what happens. None type object has no attribute get. So there might be, okay. Oh, okay, so you can have a none over here or a none type attribute. Okay, so what we're going to do, we are going to get rid of these nuns over here. I'm curious how the none is stored because usually it's nan inside. So what if I do this? So like, let me go to test.json and we'll do dot drop a. Just get rid of the null values. Okay, cool. It seems like that worked. Cool. All right. So what we need to do in that case is new data equals new data dot drop na. I think, let's see, I only want to drop it for certain columns. So drop na pandas. Let's see. I think I can do it like this. Columns equals, and then I just want to drop NA or drop it if there's nothing there. Then we can copy this launch over here. So we get rid of all these rows, put them in there, and then we can just copy this and do the same thing for longitudes. All right, and then we'll do data. We want to drop the NAs. So like the nuns, for example, over here. We want to drop columns. I mean, well, we want to drop rows where we have no location data. If we don't have a latitude and longitude, we want to drop that data. So, excuse me. We're going to do new data. I'm just going to copy this over here. And I think we're going to give them columns over here, right? Oh, I forgot to say. New data latitude equals latitudes. New data longitudes. So put this over here. And then if we put longitude over here, then I think we have our, I need to return that. I think we have our new data set. Well, we want to drop the business address JSON. I just realized that. So all right, let's try this out. So data cleaner, and then we'll give it the test data set and see what happens. Drop NA got a unexpected keyword columns, maybe. Okay, sorry, subset was what I meant. So let's try subset. Okay, there we go. Yeah, we can post count, the followers, business category name. We don't really need the account name. That's not all that important right now. Maybe we'll add that in future iteration. But that's why you turn everything into a function, right? That way you can easily change stuff in the future. So now what we need to do is we need to read through every single one of these chunks over here, and we need to save everything into a new cleaned data. We'll call it dashboard data folder. So let's go ahead and we go. Let's go ahead and create a list of all the files we want to read. So we're going to import OS, which is going to let us use some OS commands. So we'll do os.list_dir, this directory. And we'll want to list the directory inside data, I believe. Yep, there we go. And then let's create a list of file names for us to use with that. So we'll use list comprehension. And actually, let's do this correctly. os.path.join. That way it works on a Mac or a PC. Because what happens is on Macs, file names are device like this, right? On Unix-like systems, right? So it would be like that. But on PCs, it is they use a backslash for some reason. So you have to do it like this. I don't really understand the logic behind it, but it is the way it is. And if you use os.path.join, it'll detect your operating system and just change the way, like which slash it uses based on the operating system. So uh, data with I for I in. I think that's it. Yep. Data. Yeah, there we go. So we'll call this file paths. So file paths equals that. Then we'll say I guess we use another list comprehension. So we can do. Oh no, we can't use list comprehension because we had to actually read in the file, right? So for file in file paths. We might be able to. We might be able to turn this into a list comprehension. I love using list comprehensions where I can because it uses fewer lines and they're not too hard to read once you get like used to Python. Honestly, they're fairly easy. So what we can do, pd.read_json, um, file for file in file paths. So this isn't, I've never used a function inside of list comprehension. I'm not even sure you can do that, but let's see. So what we're doing over here is we're saying, go to the file paths list, which is a list of every file path. Get each item inside it, like so each file, then read that JSON and then input it into that data cleaner function we created up here. So, and then if I do pd.concat, that will take all that list of data frames that's being output and then stack on the top of each other. So let's see how this works. Okay, so I mean, yeah, the basic level, I guess it's working. The only problem is I don't know how long this is going to take. So I don't know. So we have an error here. Length of values does not match the length of index. Oh, interesting. Okay, so basically what it's saying is that latitudes, or this list latitudes over here is longer than the data frame. The problem with putting stuff inside functions is that these variables are now all lost. Like new data is not a variable anymore because it's inside the function. That's an interesting error. Oh, you know what? It's because of this. But I already, yeah, so I don't need this anymore, do I? Because I've already dropped the NA up here. So then this has to be the same length as this now. Because, my bad. This is my mistake. I should have. There we go. I was using that old test. So that's the problem with like writing logic in one place and then like just copying and pasting it. It's easy to just forget that. Like I make that mistake so many times. Okay, there we go. This should fix it. I probably should save this as a variable that way I don't have to run it again. In fact, let's do that right now. That way we're not wasting time. So we'll say final data frame equals, and then we want to reset the index at the end, and then drop the column that'll show up. Yeah, and then we'll save it as a variable, and then I can always look at it later. All right, looks like we are done. So let's go ahead and see. That took 4.5 minutes. So I'm really glad that I actually did save it as a variable, so I wouldn't have to run it again. Okay, there we go. 364,000 rows of data, lats and longs. Let's make sure the lats and longs are stored as floats. So we'll check the D types. Yep, those are floats. That's good. Uh, yeah, everything is exactly what it should be. Okay, let's go ahead and save this then. So we're going to do final data frame dot two. I like to save things as pickles when I can. It's not Pickles are not always the best format to save things. So a pickle is basically like a serialized file, I believe, that like you can store any Python object inside. So what happens is if I store this pandas data frame inside it, it'll be like I can extract it in the exact form I saved it in. The problem is newer versions of pandas cannot always read older versions of pickle files, or the other way around. I forgot which way it is. So it's not like a CSV where CSVs like are infinitely readable. Um, but because I'm going to be working, like I clean the data, I'm going to be reading it on the same computer. I'm just going to save that as pickle. So we're going to go ahead and save it as clean data, and then account data dot pkl. Okay, so we should have it right over. Oh, sorry, I meant to put it in dashboard data. So we should have it right over there. Cool. All right. So we have cleaned our data. So we parsed out the geographic data, we've limited the columns, and we've created the clean data set. So we've done that. Now let's go ahead and create our machine learning algorithm. So I'm going to do that over here. So we're going to be using something called a k-means algorithm. So let us and let me see if I can illustrate to you guys what a k-means actually is. K-means. So it's a form of unsupervised learning. What is unsupervised learning? Unsupervised learning basically means you give your machine learning algorithm a set of data, and you tell it, um, I have no labels for this. I have no I don't know what the groups in this data are. You group it for me. You tell me how this data should be grouped, and that's what this clustering algorithm is. So, for example, that we have our x and our y axis over here, right? And what this algorithm did was we basically defined how many categories we wanted. In this case, we wanted 10 categories, 0 through 9, it's 10. And it automatically figured out where exactly those 10 categories are split. It clustered everything by itself. That's what the k-means algorithm does. And if you think about it, we have longitudes and latitudes, which are basically respectively y and x axes. So we can put that into our algorithm, and then we can enhance our algorithm by using this. Let's see. K means by using there's a weight that we can use, and I'll find it in a second. By using like a weight parameter in order to actually provide more weight to clusters with like more followers, for example. So let's say, for example, this was a map of the U.S. and like this is New York over here. New York's probably going to have more followers than most parts of the country, or like LA. You know, LA would also have a lot of followers. Like Miami might have a lot of followers, right? So what happens is this red section would probably expand over here. So that's what we're going to be creating. I thought. Okay, yeah, it's under the fit. Yeah. So you put it under sample weight under fit. Okay. Yeah, let's go ahead and do it. I'm gonna actually just see if I can get a I want to predict. Yeah, I guess I want to fit transform is what I want. So from SK, so we want sklearn.cluster dot sklearn dot cluster import k means, and I can do k means dot fit transform, and I can give it a series of x values, and then I can give it sample weights, and I think I tell it what column that is. So here's what I need to do. I need to, if our final data frame looks like that, right? Then let's say I want to give it the followers as a column, and then latitude and longitude are x and y. Then what I would do is I would say, so fit underscore transform, that's this method over here. So x, y, y is ignored, it's just there for consistency in the API. We'll be using just this x over here. So I'll say x equals, and x is always capitalized for some reason. And let's see if I can do final data frame and then latitude, longitude, and let's say sample weight is followers, for example. I might be missing some, I'm definitely missing something over here. So k-means clustering, usually Geeks for Geeks or some other website will have like an actually worked out example I can copy. So let's see. Fit transform. No, not this one, because we don't have to do any transformations of the data. We've already done all of our transformations. Let me see if there is. Let's see if we can read this error here. So k means fit transform. Oh wait, I forgot. I need to create a k means. I think I need to do it this way. 1 second. So there's one or two things I need to do. Either that will work. There we go. Yeah. So basically, I didn't instantiate a k means object. That was it. Um, so by doing this, I've instantiated a k means object. Usually, the way people will do this, they'll say like they'll do it like this. Yeah, so they'll like do it like that, and then they'll do clustering algo dot fit transform. Um, you can also just do it like this. Like, I mean, why even add an extra line of code when it's as simple as just doing that? Okay, cool. So this is our list of latitudes and longitudes, I believe. Well, what I really wanted is I wanted this to turn into to give me a bunch of clusters. So that's what we're not getting over here. New data to transform. Oh, you know what? I think this is what I need to do. So let's just call this test. As you can tell, I like using the variable test. And I can do test dot, there we go. Yep, and those are our cluster centers. And I can even do test dot labels. There we go. And that's each of our groups. Um, Now, where do I define the number of groups I want? I think there's a place to define, yeah, n clusters, that's it. So n clusters, I can define this to be whatever I want. So let's just say I make it like 3, right? And then we'll have 3 clusters, and I can show you guys how this actually works. So let's go ahead and get rid of this. And then we'll say label cluster labels equals this. And then we'll say, we'll call this our plot data frame equals final data frame dot copy, and then plot data frame. Whoops, that's not what I wanted. Clusters equals cluster labels, and then so then we'll have a data frame that looks like this. So you'll see we have our clusters over there. Then what I can do is I can do import matplotlib.py plot as plt, and then I can do plt.scatter, and then I think scatter takes an x equals, and then x will equal plot data frame, and then on a map latitudes are x's, and then longitudes are y's. And then I think color should be, I think I can give a separate value for color. Let's see. Let's see if that works. No module name matplotlib. Okay, let's go ahead and download that. So we'll go ahead and open it into the terminal. Pip install matplotlib. Okay, let's try this again. It might take a second because matplotlib very inefficiently plots points. We have 300,000 points we need to plot, right? And matplotlib will actually try plotting every single one of them, even though you won't be able to see like 90% of them. Okay. So I don't think that came out exactly as expected. Let's try reversing the y and the x. It looked like a world map kind of sideways, but I couldn't really tell. Yep, it was a world map sideways. So as you can see, that's clearly North America, South America, Europe, and Western Asia, Africa. Um, it's kind of interesting. It looks like nothing's happening in like the northern part of Africa near Europe, but it could also just be a distorted map. And then India, Southeast Asia, Australia, and Asia there. So clearly, our machine learning algorithm does work. And if I go ahead and change this to say 5, right? If I increase the number of clusters, because we have 3 over here, right? And then I run this again, then we will get more clusters. There we go. 1, 2, 3, 4, 5 clusters. Sweet. So now, in our list of things to do, we've created our machine learning algorithm. Now it's just time to create the dashboard. So to create the dashboard, we'll be using a service called Streamlit, which I really enjoy using. So we will create a new thing, and we'll call it dashboard.py, and then import Streamlit as st. Okay, so we have our clean data. We will eventually have to refer to it. So we'll say data equals pd.read underscore pickle. And It'll be dashboard data slash account data.pkl. So now we have our data in there, and then let's start constructing our dashboard. So we have our data, and then we have our machine learning algorithm right here. This is our, so I mean, again, this is the crazy thing about machine learning, right? Like these days, you can like create algorithms with just a single line of code. So somebody that might import as well. So from sklearn.cluster import k-means, and we'll call this our ML algo. And we will handle this in a second because actually what's going to have to happen is we're going to have to replace all these. We're going to have to replace all this stuff over here later. So I'm going to go ahead and just comment this out. And then we'll go ahead and add some stuff over here later. So we'll say ML. So we have our clean data right over here. We have our machine learning algorithm right over here. Let's go ahead and start creating our dashboard. You ready, guys? Let's do it. So I think what we need to do is we need to import Plotly as well. So Plotly graph objects. We'll be using something called Plotly graph objects because it is a lot more detailed than Plotly Express, but harder to use. So from Plotly, import graph objects as it's usually imported as geo. And then from Plotly, import Plotly underscore express. Okay, maybe not. Yeah, we'll later. So data, Wikipedia.read pickle. Okay, so we've read in our data. Let's go ahead and create our dashboard. So I think we can start with st.title. And then we'll call this global Insta centers of influence. Oops, I did not mean, yeah, sorry, I did not mean to run it that way. So what I'm supposed to do is I need to run it as Streamlit run. I think it's dashboard.com. Okay, so you can't run it that way. I forgot. So it's like Python. Yeah, if you can't run it that way, and like this happens on Windows computers a lot. So I think you do Python m streamlit run dashboard.py. Okay, so we have our dashboard over here, but for some reason, my title's not showing up. So let's go to the Streamlit documentation and see how that works. So Streamlit docs, the API version specific what I'm looking for. Right, so I thought I actually wrote it like that. Like you're supposed to just put it in there, I believe. So I'm wondering why it doesn't show up over here. So let me see if I can just get a quick guide to creating an app. Yes, import Streamlit as ST. So interesting. I don't know, something, nothing's showing up. Then we can cache later, but yeah, you're supposed to just declare components one after another, and then they should show up. So why isn't my title showing up? st dot markdown. Let's rerun it. Okay, there we go. Yeah, I guess it was just a small glitch. Cool. So we have our title over here. Now let's go ahead and put in our Plotly graph. So I want to go ahead and I want to use something called a density map box, because what a density map box does is it'll take all your points and kind of aggregate them together in something that like looks decent. Um, so Plotly density map box. And I don't want a density map box. I'm going to do a graph object. So graph objects is a form of Plotly that uses that's a lot more complex to execute, but way more detailed. I think. This is Plotly Express. I'm going to do it in. Here it is. So this is how you do it. So I can just copy this code over here. I've already done that import. It's created this update, and then what I would do is I would do st.plotly chart, and then I just put fig in here. So you'll see we're reading something from our GitHub. Uh, we're creating a figure object, and then we're updating the layout with two different things. And then if I save that, and then go over here and I hit always rerun, we should have a basic plot over here. And you can see what it does. I think it's like a volcano thing, or like, yeah, like it's like volcanoes or something like that. You'll see as we zoom in, it like splits apart so you can see more detail in more detail like what exactly is happening over here. So now I want to do this for our groups over here, for our longitudes and latitudes. So what I can do is I can get rid of this, get rid of that, and then let's go ahead and create our machine learning algorithm over here. We're just gonna leave sample weight as followers for now. Data equals latitude and longitude, and then over here, I just need to put in data latitude, and then over here, you put in data longitude, and then z. We don't have a z in our case, so I don't believe we do. Well, I guess maybe z can be. Well, let's leave that for now. And I don't really like this map box style. It looks kind of ugly in my opinion. So let's go ahead and see if we can change the style. They have a list of styles that you can use. I have no idea how like I would be able to do anything without Google, because I just like need it for everything. There's a style I really like called Carto Positron. So we will use that. And then the center long, we don't necessarily want to fixate on that. All right, so let's go ahead and rerun and see what we get. So you'll see there's just entirely too much data to look at it. But if you zoom into, like, say, North America, then you'll start to see where the centers are. So Texas is a great example, because Texas is a great example because it's a relatively large state, like this. And there are really three major centers of population in Texas. There's the Dallas-Fort Worth area, there's the Houston area down here, and then there's like the San Antonio-Austin area over here. And you can see that's clearly where our clusters are being created. This is our machine learning algorithm at work. Now, the problem is I can't tell the difference between any of the individual groups. And I think in Plotly, what you have to do is you have to actually add each individual layer one on top of another in order to actually get them. Plus, this is way too small. I'm also going to reduce this radius to 1 to see if that makes this any easier to read. There we go. Okay, that is actually a lot easier to read, but it looks like it's slowing down a little bit because it has to render all the stuff all at once. So we can play around with that a little bit later. Let's go ahead and make it like 3. And note, every single time I save this file, it's rerunning that machine learning algorithm. I mean, obviously the results are going to be the exact same. Um, but and you can see within Africa, like Africa is actually a great example, like where the Instagram activity in Africa happens. So like very little of it in the Middle East part of Africa, but like Nigeria and stuff, Western Africa, you see a lot of Instagram activity over there, a lot in South Africa, and then it looks like I'm guessing this is another really populated area of Africa, like the Kenya, Tanzania area. Um, my very basic knowledge of Africa is like, yeah, these are like the heavily populated areas with access to technology. Like the Congo has a ton of people, I think, but I don't know. My understanding is it's not a particularly well developed country. But Nigeria, for example, like I mean, it's still developing, but is one of the more developed parts of Africa, along with South Africa. And then obviously, like India, you have all of that. Japan is like a huge bright spot over there. China obviously has very little activity because Instagram is basically not allowed over there. Uh, cool. So let's go ahead and see if we can create, like separate out the clusters by color. Um, and the way you do that in Plotly with figures is you need to create like a for loop, right? So we're gonna have to create a for loop that goes like this, like for um, cluster in, and then it would be, oh, you know what? We didn't actually create our data frame over here. There we go. So plot data frame equals, and then cluster labels here. So now we're running our machine learning algorithm. We're getting the labels out of it. We're creating a new data frame for plotting purposes. Then we're creating a variable called clusters, plot data frame. Okay, cool. Happens if you just take this over here and you say z equals this. I've never actually used the z variable here for clusters. Oh, whoops, I need to comment that out. Hmm. Oh, interesting. Yeah, so it doesn't separate them by colors. Okay, so yeah, that's what I thought. It's not actually going to help us. So we do not need that. So what we need to do is we need to do for cluster in cluster labels. So for every cluster, and then I'm going to create a counter here because what we need to do is we need to create a figure object, and then on top of the figure object, we need to keep updating the traces to add more figure objects to it or add more traces to it. So I'm going to do for cluster and cluster labels, if counter equals 0, then basically just copy this logic over here, create the figure object we need. And we need to filter the data frame to only like one cluster at a time. So temp equals plot data frame where clusters equals cluster. And actually, we'll need this for any logic that we use, so I'll put it up here. Then we need to switch these out over here. And let's just shrink this. Why use more lines when we don't have to? I shouldn't save because, and then else. Oh, and then counter plus equals 1. Otherwise, so if the count if we've already plotted, if we've already created a figure object as we did over here, fig dot update traces. And traces are basically the individual mark on the plotly object. I think I can just do it this way. I think. So let's see if this works first of all. So it'll plot everything. Everything will be the exact same color. I just want to make sure it actually works. And it's a bit slow because it has to run this on top of running my screen recording software. And I've made very little effort to optimize this process. Mhm. Maybe let's get rid of this and then let's end this and let's try it again. Looks like it's a bit slow to react. Let us close you and then we will open it again. Hopefully that killed the terminal. Let's run it again and see what happens. So I'm trying to see if there's anything I did that. Okay, I created. Did I create a? I think. I think I created. Yeah, it's a for loop. So for loops aren't infinite. They. Yeah, and then I mean I don't need to add a counter down here because it's not a while loop. A while loop can run forever, but for loops can't run forever because they're iterating through a defined list. So for cluster and cluster labels, so we created this data frame over here. If counter equals 0, because we start off over there, or is equivalent to 0, fig equals this, and then add one to the counter. That way it doesn't go back to this if condition over here. Otherwise, update traces as an add more. Temp latitude, temp longitude, radius 3. And then this is not really necessary. I don't think this is, because as long as it's not 0, we're good to go. And then update the layout of here. Yeah, because it's a for loop, so for loops can't run indefinitely as far as I can tell, or as far as I know. Like, because your list has to have an end to it. I guess unless the for loop is adding stuff to that list, but that's definitely not what's happening here because it's not being called anywhere. It honestly might just be a. Let's try this. It honestly might just be that my computer can't handle recording and creating this data frame at the same time, or creating this dashboard at the same time. Yeah, even stopping it's taking a while. But now that I've added this print over here, then we can see where the slowdown actually is. Okay, so we do have an infinite loop. Ah, I see the problem here. Okay. So what happens is I'm iterating through cluster labels, so no, I don't want to actually do that. I want to iterate through each label in the data frame, which means that I actually have to do this because cluster labels is a 300,000 row data frame or list. Dot unique. There we go. And then let's end this. We'll close this as well. Okay, cool. So it's not my computer that's the problem. It was my launch pad was the problem. So that, yeah, why debug when you can just use a print command to figure out what your mistakes are? This should run a lot faster. Okay, so didn't add anything else. Let me try this. Let's see. So fig update traces. I'm gonna have to use a different method over there. Figures is dictionaries. Interesting. Oh, interesting. Okay, so maybe I can do maybe instead of update traces, I need to do fig dot density map box and then just put these parameters in there. Because it looks like it's only adding the one and then it doesn't add anything else. There we go. Perfect. So now I know it's added every single cluster. Now I just have to color them differently. So density map box color. So I want to change the color. This is the Plotly Express. I want the graph objects implementation. Because Plotly Express, you can do Plotly. You can either implement it as Plotly Express or graph objects. So graph objects, Plotly, density math box. Yeah, maybe it's color bar, color scale might be what it is. There we go. Yeah, so I think it's color scale. So let me copy these over here. Looks like there's a list that we can use over here. And then we will say colors equals. That makes sense. Okay, there we go. I guess it was just be a line break. There we go. So then we will say color scale equals colors, and then it's a list over here, right? Then we're gonna select the color at the element counter. All right, let's try that and see what happens. We should get different colors now. There we go. These aren't the best colors, but it does illustrate my point. Now, one thing I want to do is I do want to increase the size. then maybe that is over here. Oh, and also I know, okay, cool. So we did increase the size. We have to increase this width over here, and we need to do that through Streamlit because Streamlit automatically defaults to having the width be very small on their apps to make things seem more, I guess, mobile friendly. Yeah, it is kind of the angle at it. So Streamlit full width page. Yep, this is it. st.set page config wide. And you just put that at the top. It just needs to be the first Streamlit command, I believe. Whoops. There we go. Okay, so now the width is kind of messed up, but maybe if I refresh it, then it'll look better. Oh, interesting. Okay. Let me. There's probably a width parameter over here. Ah, there we go. Okay. So let's make width 2000 in that case. Cool. So now we have a huge map that we can work with. I'm going to make this 1300, and I'll tell you why in a second. There we go. And the reason I want to do that is because I want to add a sidebar where people can change some of the parameters over here. So there's a couple of things I want people to be able to change the values of. So we're actually going to have to take this and put it down here. So we need to change I want people to be able to change the number of clusters. And I want them to change this value over here. So let's see. If I wanted them to do that, there's something called, so I think it's like with st.sidebar. So let's see, Streamlit sidebar. Like if you do this, then you can create a sidebar basically. Yep, there we go. With st sidebar, and then I don't need this over here. And then let's say clusters equals st, so Streamlit dot, I think it's slider, select slider maybe. Uh, Interesting, it's not working. Let me see if I can input widget, select slider, labels, options. Okay, cool. Yeah, labels and options. Those are the two things we need. So label equals number of clusters, and then options will be range from anywhere from 2 to, let's say, 10. So I want people to be able to select 2, 3, 4, 5, 6, 7, 8, 9, and 10 clusters. By doing 11, it'll go up to 10. And then I need to take this. Oh, maybe I want to make sure I didn't name something else clusters as well. I don't think so. It doesn't look like I did. Also, I don't need this. I need, it looks like I am referencing cluster labels before I actually have cluster labels. I need to put that over there. And then probably paste this as well down here. And then n clusters, that's going to equal this. And then let's say the value equals 2 by default. So now you'll see a sidebar came there. That's why I reduced the width of this right here. And now we only have 2 clusters. And it makes sense. North America will be its own cluster, and then the rest of the world would be its own cluster. Um, which is pretty crazy if you think about it, because like there are already a ton of people here. So that really shows you just how much activity is going on in North America. If I change it to 6, should be approximately 1 per continent. Yeah, so North America and Central America get one, and a little bit of South America. South America gets its own. Europe, Western Asia, Eastern Asia, and Southeast Asia, and then Africa. Not having China in this data set is really funny because, like, it's just like the biggest population center of the world just doesn't have much data to work with. Um, but the cool thing is you can like zoom into countries, right? You can kind of see where like the large population centers are, or the large activity centers are, right? Like so in India, it looks like there's a lot of stuff down here in southwest India. Obviously, Mumbai has a lot of stuff going on. New Delhi, the NCR. Um, you know, in it looks like Saudi Arabia doesn't have that much Instagram activity going on, but like the UAE has a ton, especially in Dubai right here. You can see like Abu Dhabi has very little, but Dubai has a ton. So what this does, this tells you like, where all the activity is going on. In France, it looks like southern France has some stuff going on. Otherwise, it's mostly Paris. Central Europe has a ton of activity going on. It looks like a lot of people do stuff near the Dutch areas, Amsterdam over there. And you'll see it aggregates and disaggregates based on how much you zoom in. London is much bigger than Leeds or Manchester looks like. So there's a lot of great information in this data set. We can increase and decrease the number of clusters as we choose. The next thing I want to do is allow people to decide what the weight should be. So then let's go ahead and do, I think we need something called a select box, which will give us like the option to select from a couple of fields. And so if I go over here and I quickly get our little data frame. Oh, let me, oh, here it is. Yeah, this is it. I want people to be able to specify where the actual weighting comes from. So these are some of our groups. So I'm going to go ahead and create weighting equals st dot select box. And then all of these components need a label, I believe. Our label is going to equal select weighting parameter. I'm guessing there's probably something called options over here. Turn this into a list. There we go. And then I want to add one more just for accounts. So we do that. And then what we do is weighting, we'll create something called weighting logic. So if weighting equals account, then none. Wait, sorry, there's no then in Python. Else, let's see, final weighting. Else final weighting equals weighting. So what this is going to do, oh, sorry. Sorry, we need it to be like this. There we go. So now what this is going to do is we can replace this with final weighting. And this is going to show, this is going to do something really cool to our data. So let me show you guys. So we'll rerun it. And what happens is basically what this is doing is this is showing us, okay, if we assume every account is worth the exact same amount, then this is what the map looks like. So it's basically just splitting up things based on like where things are. But what happens is if we say, okay, accounts with more followers are worth more, look at how the map transforms. you'll see all of a sudden, for example, parts of South America like get put into this North American cluster, and then India gets split up in two because of the activity going on in East Asia. So this is an example of how you can use k-means clustering to actually drive real business value. Now we can go in and we can say, okay, um, it looks like we have major global centers of influence over here, here, here. Obviously, like in Japan, you have looks like three major areas. I'm guessing it's going to be Tokyo, Kyoto, and Osaka. Maybe Nagoya. Oh yeah, Kyoto and Osaka are right next to each other, so they're kind of like one cluster over there. What you could do with this data is you could start splitting it up by country. So if you start classifying every row in the data set by country, you could filter it down, filter down the data frame, and then just show each data set by country. You could divide each country into clusters. So you can go to the US and say, okay, give me 3 to 4 clusters of major influence inside the United States. Give me like up to 10 different clusters to work with inside the United States. And you'll see every time we change these parameters, it runs the entire machine learning algorithm again. A way to make this even faster would be to, because we have a limited number of combinations, is to run every single combination and then store that data inside a data set and just have plot that by itself. So now we have 10 clusters. You'll see there's a clean split over here based on followers is verified post capture, like other things we can use as well.
All right, ignoring the fact that I've switched computers, what can we do with this data? How can we actually help our client using this dashboard and the data, this Instagram data that we've created? Well, one really interesting story in relation to this is the story of Adidas and how they actually had a business strategy that was centered around the idea of key cities. These were cities that they believed were of significant cultural importance and that people actually looked up to these cities to determine how culture in their cities would be determined. So, for example, if you live like in the Midwest of the United States, you might be following a couple of accounts and some Instagram accounts in New York City, and you might emulate those styles from New York City, and maybe buy shoes or buy brands that people in New York started wearing first. And the idea behind the strategy was to find these key cities. I think they picked out like 6 cities or something, and use those cities as kind of like individual places where they would base brands off of, base kind of designs off of in their lineup. So the cities were New York, Los Angeles, London, Paris, Tokyo, and Shanghai. So, I mean, obviously these cities make a lot of sense. Now, how can you determine in a data driven way, or how can you use data to direct your decision making as to what these key cities actually are? Well, one way that I think you could do that, you could come to this conclusion, and one way that you could actually do it is by using Instagram data. So we have our Instagram data over here, right? And I have a hypothesis that the cities that are most influential in the world from a cultural perspective, right? Especially with things like fashion, are going to be cities with the most Instagram account followers. The basic logic I have over here, my hypothesis for this, right, is that let's say you live in, for example, Dallas, Texas, where I'm originally from. Many people, there probably aren't that many people in various parts of the world following an account that's based out of Dallas, Texas. But I would assume that there are a lot of people who follow, like, some girl who has like a fashion blog running out of New York City, just because it holds this very important place in the cultural, mindset. So following that hypothesis, right? Because that's how a lot of data science works. You start with a hypothesis and then it kind of like you kind of test it from there. Let's see if we can figure this out for East Asia. Now, obviously, the data set we have over here isn't geocoded and doesn't have countries inside it. So, what I would actually do if I was doing this for a client is I would go ahead and geocode all these latitudes and longitudes to get a country name for every single value that we have over here. But given that we don't really have the time for that, let's just use a quick longitude measure. So, I'm going to go to this map over here and I'm going to just define East Asia as anything east of 105 east, or maybe even, let's say it's anything after maybe 95 east longitude. Let's call it that. What I can do is I can go to our data set over here and I can just filter our data to get, and the reason we're doing this, we want some really actionable insights, right? So what I'm going to do is I'm going to go ahead and take the longitude column. Remember, longitude goes up and down on the map, latitude goes left to right. And let's just say the longitude is greater than, I think I said 95, right? I'm going to save that. And then we're going to rerun our dashboard. And it should more or less pick Australia, East and Southeast Asia. And there you go. As you can see over here, we've limited our data to just these core areas over here. And already you can see some very interesting patterns. Obviously, Japan, dominates an entire section. China's not really important in this case because if you're trying to use Instagram data to devise what are the most important cities in the world, obviously China's not really going to show up because Instagram's not a big thing over there. But then it looks like maybe this might be Malaysia, but specifically Singapore over here has a huge cluster of values. And I'm guessing this is KL. Yeah, this has to be KL, Kuala Lumpur. Or, yeah, someone correct my pronunciation over there. I'm pretty sure I'm pronouncing that incorrectly. Um, and I'm guessing this is, yep, this looks like Indonesia over here. And then it looks like Eastern Australia and New Zealand have their own areas. So let's say I was an executive, right? And I wanted to determine, okay, like where should we look for the cultural centers of um, East Asia, not including China. And actually, let's even just remove Australia from the equation over here, right? Because Australia is obviously culturally very different. Um, we will call that negative 15 degrees latitude. So let's go ahead and copy our logic over here. And we can even just latitude. I think it's greater than negative 15 is what we're looking for. And that should remove anything from Australia and New Zealand. Yep, there we go. Perfect. So now we're just looking at East Asia, and we're just not worried about China. So looking at this map over here, let's say I wanted to find three major areas of cultural influence in East Asia. I'm going to take our number of clusters over here, and I'm going to reduce it to 3. And you'll see it reran the machine learning algorithm. Remember, every single time we run this dashboard, it reruns that machine learning algorithm. And it looks like, Seoul is right over there. Obviously, North Korea is completely empty, but Seoul is right over there. Looks like we have a lot of stuff, especially in the Kanto region of Japan. Um, and then, quite honestly, it looks like Indonesia has a lot of stuff going on. I wonder what city is over here. I'm guessing it's Jakarta. Yep, this is Jakarta. So based on account count, I would actually say maybe Jakarta is somewhere that I would look that I wouldn't have thought about earlier. If you just asked me prior, I would have said, oh, obviously it's going to be Tokyo, Seoul, and like maybe Singapore are the culturally most influential. But let's see what happens if I switch this to a follower. So basically, we're going to weight each of these points using followers instead of using account count. You see, we might get a slight change. So it looks like in this small of a geographic region, it doesn't change too much. Although it does look like the Jakarta cohort may have shrunk down a little bit versus the Singapore one. And the KL one's quite huge too. So, and this is where, we would start to tune our machine learning algorithm, right? Because obviously in places like Indonesia and Malaysia, the populations are quite large, which may or may not have to do with the influentialness of the city. So what I might even do is I might even just remove any account that has less than 1,000 followers, for example. Let's just say anyone with less than 1,000 followers, we just won't call that person particularly influential in the fashion space, for example. We can cut our data that way. So this is kind of just to give you guys an idea of what are some like real insights you can gain from this data. So, obviously as, we expected, Tokyo is just probably the biggest area over there. Seoul is also quite large. Um, Hong Kong has some stuff going on over there. But then after that, I would say it's probably KL, Singapore, and Jakarta that are the areas of greatest influence in East and Southeast Asia. It looks like Taiwan has some stuff going on as well. Taipei or is that Taipei? I think that's Taipei, right? Yeah, that's Taipei. So, kind of to give you an idea of what you can use machine learning for with the power of internet data scraped using, something like Bright Data, a service that lets you, scrape millions of accounts off of Instagram. I hope you guys found this really useful. I personally think this data was fascinating to deep dive into, and I really hope that you guys got something out of this, both from a coding perspective, but also from a trying to use analytics to actually drive some result in your company. And hopefully the client will be very happy with our results over here. So thank you guys so much for your time, and I hope you have a good day.